Even after being retired, an old spark plug can become a unique DIY accessory if you know how to repurpose it when you pair it with a grinder's washer nut. You essentially turn two seemingly discarded items into a solid metal detail with rugged, raw aesthetic. The spark plug, with its thick threads and signature white ceramic tip, when fitted together with a flange nut, can form a support point, a handle, or even a decorative garage-style pin. Repurposing scrap materials with your own hands not only saves money, but also brings a satisfying feeling that defines true DIY spirit. Simple, rustic, yet full of personality. Instead of letting them rust away in a drawer, sending them for recycling ensures the materials are recovered and transformed into something new. It's another simple DIY-minded choice. Responsible, practical, and respectful to things we no longer use. You can grab a spring that fits snugly around the spark plug. Sliding the plug into the spring instantly gives it a new mechanical look, almost like a small custom-made component from an old machine. At the threaded end of the spark plug, I'll mark off a section using the angle grinder's flange nut. Attach the spark plug to a drill so it can spin steadily. Then use a cutting wheel to carefully slice through it right at the section you previously marked. Let the drill hold the spark plug firmly for you. This keeps it centered and makes the cut cleaner and more controlled. After cutting it, the inner core will be exposed. Here's the English translation. Attach the threaded end of the spark, plug to the drill, and grind down the top portion. As it spins against the grinding wheel, the tip gradually forms into a clean, tapered point. The more you refine it, the sharper and more precise the tip becomes. At the core section I just cut off, there's a thin outer shell surrounding it. I'll use a hammer to break that shell away, tapping along the edge until it loosens and separates. The material is usually brittle, so a few firm, controlled strikes are enough to crack it open and remove it cleanly. Once the outer layer is gone, the inner core is fully revealed, making it much easier to shape, clean, or repurpose for the next step of the DIY project. Next, prepare a cylindrical piece of wood with a diameter that fits snugly inside the angle grinder's flange nut. Place the flange nut on top of the wooden cylinder and mark 4 points around it where the holes will be drilled. Align the nut carefully so the markings sit evenly, ensuring the holes will match its shape and keep it centered. Drill the 4 marked holes, keeping the drill straight so each hole goes down clean and evenly. After drilling the holes, place the flange nut back on top and secure it using screws. Tighten each screw gradually in a cross pattern to keep the nuts centered and firmly press against the wood. Once all the screws are fully seated, the flange nut sits solidly in place, creating a strong and stable connection between the metal and the wooden cylinder. Drill a hole straight through the center of the wooden cylinder. Make sure to keep the drill perfectly aligned so the hole runs cleanly from one end to the other. This hole also exposes a bit of the plastic from the spark plug, which makes it convenient for threading an electrical wire through. Now, moving on to the wiring part. Select a suitable electrical wire that fits through the hole in the wooden cylinder and the spark plug core. Strip the ends carefully to expose the conductor. Connect the electrical wire to the exposed core of the spark plug. Make sure the wire makes firm contact with the metal, and secure it by twisting or soldering if needed for a solid connection. Solder the connection to reinforce it and make it more secure. Apply a small amount of solder to the joint between the wire and the spark plug core, ensuring it fully coats the contact. This not only strengthens the electrical connection, but also prevents it from coming loose over time. Once cooled, the joint should be solid and stable, ready to safely carry current for your DIY project. Thread the electrical wire through the wooden cylinder and then screw the spark plug securely into place. Make sure it sits tightly, with the wire running neatly through the central hole. This step locks the spark plug firmly onto the wood, while keeping the wiring organized and protected. Next, I'll attach the spring to secure it onto the spark plug. Now it's starting to look more like a miniature welding tool, with the spark plug, wooden handle, and spring all assembled. This spring adds elasticity, allowing for better control over the pressure and timing of each spot weld. It acts like a small shock absorber, so you can apply consistent force without straining your hand, and it helps regulate how long the contact lasts. With a spring in place, the DIY tool feels more responsive and precise, giving you greater control over each operation while maintaining that mechanical, workshop-style charm. With the remaining end of the wire, I'll attach a crocodile clip. This allows for a temporary but secure connection to a power source or the object being worked on. The clip makes it easy to complete the circuit, adjust positioning, or disconnect quickly when needed, adding both functionality and versatility to the DIY tool. I'll need an additional length of electrical wire with crocodile clips on both ends. One clip will attach to the metal piece that needs welding, while the other connects to the power source. This setup completes the circuit, keeps the metal securely grounded, and ensures electricity flows properly for spot welding. Using clips on both ends also makes it easy to adjust or reposition the tool without soldering or permanent connections. I'll use a cordless drill battery as the power source for welding. Its compact size and portability make it perfect for a small DIY spot welding setup. I'll insert 2 flat washers into the battery slot to help fill the gap. Then use a crocodile clip to clamp them securely in place. This ensures a stable connection between the drill battery and the wires, preventing any loose contact while welding. By connecting the battery terminals to the wires with crocodile clips, I can provide enough current to the spark plug and metal piece to perform short, controlled welds. Now I'll use the setup to weld 2 razor blades together. Position the blades carefully so the points of contact align, then briefly activate the circuit to create a small spot weld. The spark plug, powered by the drill battery, delivers a quick burst of current that fuses the metal at the contact point. When I press down, the spring compresses and then bounces back. This recoil provides controlled, even force, preventing excessive pressure on the blades while allowing the current to flow just long enough to form a clean spot weld. The spring's action helps maintain precision and consistency, making each weld repeatable and reducing the risk of damaging the thin metal. This DIY spot welder is truly remarkable. Despite being made from repurposed parts like a spark plug, a spring, and a cordless drill battery, it delivers precise, controlled welds with surprising efficiency. Its compact size and simple design make it highly portable, while the spring mechanism ensures consistent pressure and timing. It combines ingenuity, functionality, and the satisfaction of creating something entirely from scratch, capturing the very essence of DIY creativity. Small, rugged, and effective, it's a perfect example of turning everyday materials into a functional tool. In conclusion, this DIY spot welder is more than just a project. It's a testament to creativity and resourcefulness. By repurposing old parts and combining them thoughtfully, you can build a tool that is both functional and uniquely yours. It shows that with a bit of imagination, even discarded items like spark plugs and scrap can be transformed into something practical and impressive. Beyond its utility, the project embodies the spirit of DIY, hands-on, inventive, and deeply satisfying.